All right. You should be on quadrilaterals, Unit 6, Notes 7. If you are on this page right here, you can go ahead and skip that one, and I will give you a filled-in version of that. But that will be covered on this set of notes as well. This is just an extra diagram to kind of help you. Okay, so quadrilaterals, Unit 6, Note 7. A quadrilateral, which this should be review, but now we're gonna kind of dive into it deeper, is a polygon with four sides and four angles. So four sides, four angles. Okay, this example over here on the left, right? That would be, that would have four different sides, and we label those A, B with the side symbol on top, B, C, C, D, and AD.
Uh-huh.
Those are all of the symbols, or all of the sides, sorry. The angles, we have angle A, angle B, oops, I wrote that backwards. Angle C and angle D, which is obvious. Okay, so we just learned that a triangle adds up to 180 degrees, while a quadrilateral will add up to 360 degrees, always. So today we're going to deal with a lot of equations where we add up to equal 360 degrees. All right, so in this example, the measurement of angle A plus the measurement of angle B plus the measurement of angle C plus the measurement of angle D equals 360 degrees. Okay, so down below in our examples, we're going to set up equations, which you might be thinking you don't need to set up an equation, you can just do it quickly in your head, find the missing part, but when it gets to more complex stuff, we want to be able to set up those equations. So our equation to solve for x here, our missing side, would be x plus all the other angles equals 360 degrees. Okay, now we're just going to solve for x by first combining like terms. So we get x plus 247 equals 360. Then we can just subtract 247 from both sides of our equation. And we're going to get that x equals 113 degrees. Now you might want to double check that to make sure it makes sense. 113 is greater than 90, so it should be an obtuse angle. And yes, this clearly looks obtuse. Go ahead and pause the video here and try number 2 on your own. All right, you should have paused here and tried number 2 on your own. You should have gotten that x equals 60. Okay, if you did not get x equals 60, then you need to raise your hand, ask for help to figure out where you went wrong. Go ahead and pause the video again and try number 4 on your own. So pause here. Okay, you should have paused on done number 4. So even though they didn't give us specifically 3 sets of numbers, we know because these are right angles that these are both at 90 degrees. So our equation would be x plus 61 plus 90 plus 90 equals 360, right? All 4 angles add together to get 360. Combine like terms by just adding these constants together, okay? We would get x plus 241 equals 360. And then we would subtract 241 from both sides. We end up with x equals 119 degrees. Again, I would check to make sure that x is an obtuse angle since I got a number right here that is larger than 90. And yes, x is clearly obtuse. Okay, now let's go ahead and move on to number 5. We're going to be using our knowledge from triangles and our knowledge from angles and quadrilaterals, going to put it all together to solve for all of these missing angles. Okay, so first let's go ahead and start off with, in my opinion, the easiest one right here, angle 2. because we can see that we've got two lines right here that cross. And that makes these two angles vertical angles, right? I'm going to kind of write that up here, that those are vertical. What was the fact that we learned about vertical angles? We learned that they are congruent. So if the left side is 73 degrees, then that other side, which is they labeled angle 2, is also 73 degrees. Okay? So I'm going to label that over here, 73 degrees. I can also label it right here if you can squeeze that in. Okay, now the other two angles, so angle 1 and angle 3, and notice that even though this is a number here, it's not saying that that's 1 degree. That's just what they're calling angle 1. So make sure you don't make that mistake that you think that's 1 degree because it doesn't have the degree sign like we have right there. Okay, so we have a quadrilateral right here. I'll line that pretty thick, right? 4 sides, 4 angles, quadrilateral. So those 4 would add up to 360. So again, we know this is 90 degrees. So we have 90 degrees plus 59 degrees plus 73 degrees plus, and I'm going to call angle 1x. That way I don't put 1 into my equation, or else I might accidentally add 1, equals 360. Okay, when you solve for x here, you should get x equals 138 degrees. So that means that angle 1 is 138 degrees. Now over here we have a triangle. And this is going back a little bit, but we know that a triangle adds to equal 180 degrees. So we have the 73 degrees that we found, plus the 68 degrees they gave us, plus I'm going to call this one y equals 180 degrees. Okay? When we add 73 and 68 together and then subtract it from 180 over here, you'll end up with y equals 39 degrees. And that is an acute measurement, right? Less than 90. And this looks like an acute angle, so that looks like it matches up. 39 degrees. Okay, go ahead and try number 6 on your own before you do get started. Just go ahead and notice. I'm going to point out a few things. So we have a large triangle here, right? That was kind of sloppy, sorry. We have a smaller triangle here, and we have a quadrilateral right here. So those are 3 different shapes that you might have to use in order to figure out your angles. Also, a couple other things to note is that this right here is a straight line. So this angle is a straight angle. And this is a straight line. So that is a straight angle, right? Even though we have this line breaking them up, we know then that the two sides should add together to 180 degrees to make the straight angle. So go ahead and pause here and try that one on your own. Go as far as you can. Okay, you should have paused here to try on your own. All right, I'm just going to start with angle 1. So I'm going to use this triangle right here to set up an equation to find the measurement of angle 1, which I'm going to call x. So that's a triangle, so that means that x plus 18 plus 94 equals 180 degrees. When you solve for that, you would get x equals 68 degrees. Okay, so I'm going to kind of label that just down here and write it in my answer. All right, moving on to the next one. Angle 2. Okay, again, so I'll put this back in that this is 68. Now, I already mentioned that before you started. This is a straight line, right? So angle 1 and 2 form this angle, which is 180 degrees. Right? 180 degrees. Now you can set up your equation. 68 plus y, we'll say. So 68 plus y equals 180. But all you really have to do is do 180 minus 68. And we're going to get that y equals 112 degrees. So angle 2 measures at 112 degrees. All right, now we can go ahead and do number 3. Okay, again, this is a straight line. So angle 3 and this 94 together, I'm going to call this W. Should add up to 180 degrees because it's a straight angle. I drew it in green in case you can't see that. When we subtract, we get that W, or angle 3, equals 86 degrees. All right, so let's label that one over here. Now I'll remind you that this one was 112. Now finally we can get angle 4 by looking at our quadrilateral right here, right? We've got 3 of the 4 sides, or 3 of the 4 angles, and we know that a quadrilateral adds up to 360 degrees. So I'm going to do, let's just call this one V. Oops, it's still in wide. Okay, so V. So V plus 86 degrees plus 112 degrees plus 90 degrees. Remember, they gave us that right angle of 90 degrees equals 360 degrees. When you solve for all of that, you're going to get that V, or the measurement of angle 4, equals 72 degrees. All right, so hopefully you were able to work that out on your own. It's a lot of steps that kind of build on each other. You just have to take your time and solve it one by one. And it might not always be in the order that they give it, right? Like up here in 5, I went for measurement of angle 2 first because I thought that was the easiest. So sometimes you might have to start at a different one, not the first one. All right, number 7, same thing that we've been doing, but now we just have full expressions instead of just numbers. So our 4 angles are still going to add up to get 360 degrees, but now we just have to make sure we're doing this, plus this, plus this, plus this, and then solving for x. So I have 12x minus 1 plus 7x plus 6x minus 4 plus my 90-degree angle. Then that all equals 360 degrees. Okay? We're still solving for x, so my first step will be to combine all like terms. So 12x plus 7x plus 6x. Remember, when you combine like terms, you look at the symbol in front. So it's a positive 12, that's a plus 7x plus 6x. Okay, when we do that, we're going to get 25x's, or 25x. Now combine all your constants, so just your numbers. So we have -1 minus 4 plus 90. That's going to give us a positive 85. So we do plus 85. And then bring down my equal sign and my 360 degrees. Now we solve for x. Your first step here would be to subtract 85 from both sides of your equal sign. Okay, they cancel here. Bring down 25x equals, this will be 275. Final step, divide by 25 on both sides. You're going to get that x equals 11. All right. Go ahead and flip on over to the back. So this is review, but it's been a while. We're just going to remind ourselves what these shapes are. Okay, so a parallelogram. All right, that one, we're just going to check the boxes that it goes with. Okay, so a parallelogram, and I'm just going to kind of draw it over here. All right, kind of looks like that. Parallelogram has both pairs of parallel sides. So Opposite sides are parallel. Okay? So this one over here says exactly one is parallel, but both are parallel. Opposite sides are also congruent. So what that means is if in my parallelogram over here, the top was 4, then the bottom length would also be 4. Okay? So then this was 3, then this would be 3. Not 4 congruent sides, but the opposites are congruent. And nope, not 4 right angles. So just those 2 check marks. A rhombus. Okay? And if you have forgotten what a rhombus looks like, we're just gonna kind of try to draw that over here. And again, I will give you your other. Okay, very similar to a parallelogram. However, this time it's a little bit different because all 4 sides are congruent. So it has the same exact things that a parallelogram has. The only difference is if this side is a length of 2, then all sides are a length of 2. Okay? Kind of like a square where all sides are the same. So it's like a parallelogram, but then we added one more thing. Rectangle, this one should be easy. Okay, I probably shouldn't have to draw this one, but I guess I will. So again, opposite sides are both parallel. Opposite sides are also congruent. Okay. Not 4 congruent sides. They're different lengths. And yes, there are 4 right angles. Okay. Square. Again, I shouldn't have to draw this one. Um, again, opposite sides are parallel. Opposite sides are congruent. All sides are congruent too, right? In a square, everything is the same. So if one side is 10, all sides are 10. And yes, there are 4 right angles. And finally, a trapezoid, which there are multiple ways to draw a trapezoid, but this is how you most commonly see it. But beware that you will see other trapezoids also. Okay, so for a trapezoid, there's only one pair of parallel sides, so only one of them can be parallel. So over here, the top, right, and the bottom are parallel to each other. So parallel means that they never cross. And then that is all we're checking off for a trapezoid. Okay, so down here, we're going to classify the quadrilaterals. You're going to check all boxes that apply. So I want you to go ahead and pause the video here and try it on your own first. Okay, you should have paused the video here. 1 second. Oops, hold on. I have to pause my video to charge my pencil. Okay, I'm back. So number 8. So you probably, first thing you said when you saw it, I'm guessing, is that, okay, this is definitely a rectangle. Okay, obvious to see, right? I shouldn't have to explain that one. But let's go ahead and see what else it is. Now, these are all going to be quadrilaterals. I mean, as long as they are all 4 sides, right? We went over that on the front, that a quadrilateral has 4 sides and 4 angles. So if it has 4 sides, you're going to also check the quadrilateral box. So yes, it's a quadrilateral. Let's check one by one. Is it a trapezoid? Well, let's see. Trapezoid requires only one pair of opposite sides to be parallel. So no, this will not work. Okay? Which means also the isosceles trapezoid is also out. We did not go over that one yet, but we will. Parallelogram. Let's see if it checks the boxes for parallelogram. A parallelogram has to have both sides, both pairs of opposite sides parallel. Yep, the top and bottom are parallel, and the left and right sides are parallel. Opposite sides congruent. Yep, and the rectangle, they're congruent. And that was it for parallelogram. So yes, it is a parallelogram. Okay. A rhombus and a square both needed to have oh no, just a rhombus needed 4 oh wait, yeah, sorry, a rectangle or a rhombus and a square. So both of these right here, rhombus and square, require all 4 sides to be equal. we can see that the opposite sides are equal, but not all four. So these are also out. And I will go over also what these mean. These lines right here, so that is one. That also has one line. That means that it's the same measurement. Just like with angles, if I had like a triangle right here, and I had an angle here, and an angle here, since they both only have one line, that means that they are the same. So then your other angle that's different would have to have more than one line. So here, since this has two and this has two, they're telling you that it's the same length. All right, number 9. Again, obviously a quadrilateral because we have four sides. Okay, not a trapezoid, so not an isosceles trapezoid either. It is a parallelogram. It is a parallelogram. It is not a rectangle. It does not have four right angles. Okay, it is a rhombus because a rhombus is just a parallelogram with all four sides congruent. So they're all 4 feet. It is not a square because it does not have four right angles. All right, number 10. Obviously quadrilateral. Yes, we see one pair of parallel sides. And I should go over that these little triangles, when they're facing the same direction, that means parallel. Okay, so that is the parallel symbol. Yes, it is a trapezoid then, because the because only exactly one pair of opposite sides are parallel. All right, and I know we didn't go over isosceles trapezoid yet. Isosceles trapezoid is the trapezoid that you're used to seeing, the one that looks exactly like this. Okay, isosceles trapezoid has these two congruent. That's why it's called isosceles trapezoid, not just any trapezoid. Parallelogram, nope, because not all sides are parallel or opposite sides. Rectangle, square, obviously no. Rhombus, no, they are not all equal. Okay, so just those two for this one. All right, if you haven't tried 11, 12, and 13 on your own, go ahead and give those a shot real quick. So pause the video here and try those. Okay, you should have paused. Number 11, the only thing you could have crossed off here was quadrilateral. It is none of these. None of these that we talked about. Okay. Number 12, quadrilateral, yes. Parallelogram, yes. Rectangle, yes. Rhombus, yes. Square, yes. It checks all those boxes. And number 13, yes, it's a quadrilateral. Yes, it's a parallelogram, and that is it. Okay? So if you didn't get those right, make sure you're just paying better attention to all of the properties that apply to the quadrilateral. So use this little checkbox up here. And soon enough, when I have this printed, you'll be able to use this to help you visually as well. All right, down here, for each quadrilateral, give me the name that best describes it. So yes, these are all quadrilaterals, but we can be a little more specific than that. So pause here, try 14, 15, 16 on your own. Okay, 14, even though we didn't exactly go over this one, the best way to describe this is by calling it an isosceles trapezoid. That is the most specific way to name this shape. Number 15, the best we can do for this one is quadrilateral, right? There isn't a specific name for this shape. It's just four-sided. And the last one, rhombus, would be the most specific. You may have said parallelogram, but we could go even more specific by saying rhombus. And finally, our last section, determining if a statement is always true, sometimes true, or never true. Go ahead and try these on your own as well before we do them together, and I explain why or why not they are true. All right, you should have done this on your own, but number 17. It says a rectangle is a rhombus. All right, is this true? Well, let's remember that a rectangle has to have both opposite pairs parallel and opposite sides congruent. Okay? And then a rhombus also has that. Then they also have four congruent sides, right? So let's look at this one. right here. This, I tried my best to draw. I'm going to classify this as a square. Okay. Is this technically a rhombus, though, also? Yes, it is. Is this technically a rectangle? Yes, it is. It meets all the categories that a rectangle and a rhombus both have. So that's an example right there where this will work. So sometimes would be our answer here. All right. As a parallelogram is a square. Again, this will be sometimes. A trapezoid is a quadrilateral. A trapezoid, an isosceles trapezoid, always has four sides and four angles. So this one will always be true. Okay? And is a square a rectangle? Well, that's actually the example that I drew right over here. Yep, that is a square, very specific, but it is also a rectangle, right? A rectangle just needed opposite sides to be parallel and opposite sides to be congruent and the four right angles. The square checks all those boxes. The square is just more specific. So always. All right, go ahead and get to your homework now.